Have you ever wondered where the moon came from and how it came to be? This celestial body, the brightest object in our night sky after the sun, has a rather dramatic and tumultuous origin story. The leading theory about the moon's formation, the giant impact hypothesis, paints a picture of a violent past. This theory postulates that roughly 4.5 billion years ago, when our solar system was just a young whippersnapper, an object about the size of Mars, casually known as Theia, had a fatal encounter with Earth. Theia, traveling at cosmic speeds, collided with our planet in a cataclysmic impact. The force of this collision was so immense that a significant amount of the Earth's outer layer and the ill-fated Theia were vaporized instantly. This superheated molten detritus was then ejected into space, forming a ring around the Earth. Over time, this fiery ring of debris began to cool down and coalesce under the force of gravity. The smaller clumps gradually merged into larger ones, in a cosmic game of marbles, until eventually they formed a single solid body, our moon. This process, while it sounds quick and easy when summarized, took an estimated tens of millions of years to complete. It's important to note that while the giant impact hypothesis is widely accepted, it's not without its challenges. Some inconsistencies between this theory and the actual composition of the moon have led scientists to continually refine it. For instance, the discovery that the moon's isotopic composition is nearly identical to the Earth's, contrary to what the theory predicts, has sparked many a debate in scientific circles. Nevertheless, this theory remains our best explanation of the moon's mysterious origin. It's a testament to the dynamic, often violent processes that have shaped and continue to shape our solar system. So the moon we see shining in our night sky is, in essence, a child of cataclysmic violence. Now that we know its origin, let's explore how the moon has evolved over billions of years. Imagine a time, over 4 billion years ago, when the moon was a hot, molten world, just beginning to cool down. In those early years, the moon was covered by a vast magma ocean. This fiery sea of molten rock in its constant state of flux was the result of the intense heat generated by the moon's formation. As the magma ocean began to cool, it started to solidify. This process formed the moon's crust, a hard shell to protect the softer interior. This crust, which we can see today when we look up at the moon, is a testament to these early fiery years of our lunar neighbor's history. But the moon's evolution didn't stop there. Beneath the newly formed crust, the moon was still active. Volcanic activity was common, and eruptions often broke through the crust, spewing lava onto the surface. These eruptions were so powerful that they reshaped the moon's landscape, creating vast flat plains known as maria, or seas, and towering peaks and rugged highlands. These maria and highlands form the familiar patterns we see on the moon's surface today. The maria, dark and smooth, are remnants of these ancient volcanic eruptions, while the lighter, rougher highlands are parts of the moon's original crust that survived this tumultuous period. Over time, the moon's volcanic activity decreased, and its surface cooled and solidified into the shape we recognize today. Yet the scars of its fiery past remain, etched into its surface for all to see. So, the moon's evolution is a story of fire and ice, of molten rock and solid crust. It's a story of a world in constant change, driven by the same geological forces that have shaped our own planet. So, the moon has had a dynamic and fiery past, much like our own planet. But what about the moon's relationship with Earth? How does it influence our planet, one might ask? The moon, our celestial neighbor, holds a significant sway over our planet through its gravitational pull. This gravitational interaction is the driving force behind a phenomenon we witness every day, but rarely stop to ponder: the tides. As the moon orbits our planet, its gravity pulls on Earth's water, causing a bulge or high tide on the side closest to the moon. But interestingly, there's also a high tide on the opposite side of Earth. This happens because the Earth is also being pulled toward the moon, leaving the water on the far side behind. So we get 2 high tides and 2 low tides every day. Imagine going to the beach without these rhythmic changes. It would be a vastly different experience, wouldn't it? But the moon's influence isn't just limited to the tides. Arguably, one of the moon's most critical roles lies in its ability to stabilize Earth's axial tilt. Now, the Earth doesn't stand upright. It's tilted at an angle of about 23.5 degrees, and this tilt is what gives us our seasons. But this tilt isn't fixed. Without the moon, it would wobble dramatically over geological timescales, leading to extreme climate changes. Here's where the moon steps in. Its gravitational pull acts as a sort of cosmic stabilizer, suppressing the Earth's axial wobble and keeping our tilt relatively steady. This contributes to a stable climate, which is crucial for the development and survival of life. So the moon does far more than light up our night sky. Its gravitational interaction with Earth drives the tides, helping to shape our coastlines and influencing marine life. And by stabilizing our planet's axial tilt, the moon plays a pivotal role in maintaining a climate that supports life. The moon, it seems, plays a crucial role in making Earth a livable planet. The moon has always fascinated humans, but when did we finally get a closer look? Our journey to the moon begins thousands of years ago, with ancient civilizations that gazed upon its luminescent surface. The moon's phases served as a celestial calendar, guiding the ancients in their agricultural pursuits. Astronomers of old, armed with nothing more than rudimentary telescopes, began charting the moon's craters and seas, or Maria, from their Latin name. Fast forward to the 20th century, the era of space exploration dawned, and the moon became more than just a celestial body to observe, it became a destination. The space race between the United States and the Soviet Union, two superpowers of the time, catapulted lunar exploration into high gear. The Soviets initially took the lead, launching Luna 2, the first human-made object to reach the moon in 1959. However, the most significant milestone in lunar exploration came a decade later. The world held its breath on July 20, 1969, as the Apollo 11 mission, led by American astronauts Neil Armstrong and Buzz Aldrin, successfully landed on the moon. Armstrong's first steps and his iconic words, "That's one small step for man, one giant leap for mankind," marked a new era in human history. The Apollo missions continued until 1972, with a total of 12 astronauts leaving their footprints on the moon's surface. They brought back moon rocks for study and left behind instruments to send data back to Earth. These missions expanded our understanding of the moon, revealing its barren landscape, its lack of atmosphere, and the presence of minute amounts of water. The moon, once a distant object of wonder, has become a place where humans have left their footprints. It symbolizes the limitless potential of human exploration and our innate curiosity to venture beyond the known. And as we continue to gaze upon its glowing surface, we are reminded of our first steps in a universe that awaits our return. We've set foot on the moon, but what does the future hold for lunar exploration? As we move forward, our gaze is once again cast towards the moon, with renewed vigor and determination. The next chapter of lunar exploration isn't just about planting flags and leaving footprints. It's about establishing a permanent presence, turning the moon into a sort of pit stop for further space adventures. Leading space agencies around the globe, like NASA, the European Space Agency, and China's National Space Administration, are already crafting ambitious plans to make this a reality. NASA's Artemis program, for instance, has set its sights on returning humans to the moon by the mid-2020s. But this time, it's not just about leaving a mark. It's about setting up a sustainable, long-term base for scientific research and exploration. This lunar base will serve as a proving ground for the technologies and techniques needed to venture even further into space. Across the ocean, the European Space Agency has a vision of its own, a moon village. This international endeavor envisions a series of lunar outposts where astronauts can live and work for extended periods. These bases could also provide opportunities for lunar mining, tapping into the moon's resources to fuel future missions, and perhaps even support life on Earth. China, not to be left behind, has its Chang'e program. Already they've made history by landing on the far side of the moon, and their future plans include establishing a robotic research base there. These moon missions are not just about the moon itself, they're about using the moon as a springboard to the rest of the cosmos. Establishing a presence on the moon could pave the way for manned missions to Mars and beyond, marking a new era in human space exploration. But these endeavors are not without challenges. Questions about feasibility, sustainability, and international cooperation loom large. Yet the potential rewards, scientific discovery, technological innovation, and a deeper understanding of our place in the universe, make these challenges worth tackling. The moon, our closest celestial neighbor, holds the key to unlocking the mysteries of the universe. As we continue to push the boundaries of what's possible, the moon will undoubtedly play a crucial role in our cosmic journey. So, What have we learned about our captivating companion in the sky? We've journeyed through the intriguing tale of the moon's birth, a celestial ballet of cosmic collisions and gravitational tugs. We've traced the evolution of our lunar neighbor, from a fiery molten mass to the serene pockmarked sphere we see today. We've pondered the profound influence the moon has on our home planet, regulating our tides, stabilizing our axial tilt, and illuminating our nights. We've shared the thrilling chronicle of lunar exploration, from the first tentative steps of robotic probes to the giant leap for mankind taken by the Apollo astronauts. And finally, we've looked to the future, a future where we continue to probe the moon's secrets, where lunar bases may become a reality, and where the moon serves as a stepping stone to the wider cosmos. As we continue to gaze upon the moon with wonder and curiosity, we realize that it is not just a silent spectator in our night sky, but a dynamic world with a story as old and as fascinating as the universe itself.